Morning, everyone. I'm going to present the article titled Synthesis and Characterization of Lanthanum Nickel 0.5 Titanium 0.5 Oxygen 3 and Lanthanum 2 Nickel Titanium Oxygen 6 double perovskite nanoparticles, written by José Córdoba Calderón, Pablo Tuza, and Mariana de Matos Vieira Melo Souza. Let's move. It's worth noting that this article was published in the Materials Journal. Let's move to the abstract section. In this work, double perovskite nanoparticles containing lanthanum, nickel, and titanium were prepared using the modified Bikini method by increasing the calcination time, the Bikini ordering, the particle size, the Néel temperature, and the magnetic moment were modified by increasing the calcination temperature. All of the previously mentioned parameters, along with the symmetry and the space group, changed. Random short range ordering and Roxal ordering of the big cations were observed for the as prepared samples. Let's move to the introduction section and talk about the perovskites, which are materials that can be represented by the formula A, B, or 3, in which A is an alkali earth, or a lanthanide methyl, and B can be a transition methyl. And the perovskite structure can be represented by octaedra sharing corners, in which the B cations are in the center of the octaedra. The oxygen are in the vertices of the octaedra, and the A cations are in the cavities between octaedra. Double perovskites are materials that can be represented by the formula AB single quote, B double quote, oxygen 6, and present three different bication arrangements: random, Roxal, and layered. These materials present electrochemical, electronic, spintronic, and catalytic applications. For example, double perovskites have been used as catalysts for the steam reforming of methane to produce syngas. Several synthesis methods have been reported in the literature to produce double perovskites containing lanthanum, nickel, and titanium. For example, Rodriguez et al. Used the Bikini method, and temperatures from 723 to 1173 Kelvin, but these authors didn't report the calcination time. Moreover, Yang et al. Synthesized these materials using the amorphous citrate method and calcination temperatures from 973 to 1273 Kelvin. Moreover, Perez Flores et al. Used the Bikini method and a final calcination temperature of 1773 Kelvin. Yang et al. Used the solid state reaction method and a calcination time of 1773 Kelvin. It's worth noting that double perovskite and the perovskite containing lanthanum, nickel, and titanium, and cobalt have been reported, which were prepared using a final calcination temperature of 800 centigrades for 17 hours. The purpose of this work is to synthesize double perovskites containing lanthanum, nickel, and titanium by using calcination temperatures lower than those reported in the literature, and also to report the calcination time. Let's move to the materials and methods section and talk about the synthesis. Double perovskites containing lanthanum, nickel, and titanium were prepared using the modified Bikini method. Initially, adequate amounts of the precursors were dissolved in water. For the case of the titanium precursor, it was dissolved in a 3.4 molar nitric acid solution. The obtained solutions were mixed and heated to 60 centigrades, in which a citric acid solution was added. Then the solution was heated to 90 centigrades, in which an ethylene glycol solution was added for obtaining a resin, which was calcined at 240 centigrades for 1 hour, and then to 450 centigrades for 4 hours for obtaining the so-called precursor powder, which was calcined at 100 centigrades for 17 hours, and then for obtaining the sample one. Moreover, the precursor powder was calcined at 800 centigrades for 17 hours, and then to 800 centigrades for 100 hours for obtaining the sample two. The precursor powder also was calcined at 900 centigrades for 17 hours, and then to 1000 centigrades for 135 hours for obtaining the sample three. The synthesized samples were characterized using the XRF for obtaining the chemical composition. In this case, the Rigaku premium spectrometer equipment was used. Also, an X-ray diffraction analysis was performed on the samples. In this case, a Rigaku Miniflex 2 X-ray diffractometer was employed, and the patterns was used to carry out a Riddle method in which the full suite program was used. In this case, the structure models of the as-prepared samples reported by the ICSD were used as starting models to carry out the refinement. And in general, the background, the atomic coordinates, the unit cell parameters, peak shape parameters, and parameters related to the equipment were refined. The B parameter was maintained at 0.5 angstroms squared. The X-ray diffraction patterns were also used to obtaining the crystallites, the average crystallite size. The as prepared samples were also characterized using a scanning electron microscopy, in which a Quanta TM40450 FEG equipment was employed. And finally, magnetic measurements from the as prepared samples were obtained, in which two equipments were employed. The first one was a MPMS-3 squid magnetometer. The second one was a SX600 squid magnetometer. Let's move to the results and discussion section. Table 1 presents the results of the chemical composition. It was observed that these values were similar to those expected from a theoretical point of view. Moreover, this table presents the average crystallite sizes for each sample obtained using the X-ray diffraction results. Figure 4 presents the X-ray diffraction patterns for the sample 1, sample 2, and sample 3. It wasn't observed any secondary phase for the case of sample 1, sample 2. For the case of the sample 3, it was observed a titanium oxide phase in a 2.72 percent amount, it means that this last sample was mainly composed of the perovskite phase. By using the Rietveld method, it was determined that the symmetry was orthorhombic and the space group was PDNM for the case of the sample 1 and sample 2, while for the case of the sample 3, the symmetry was monoclinic with P21/N space group. The results are according to those reported by Perez-Flores group and Rodriguez et al. For the case of the sample 2, this result is according to that reported by the Perez-Flores group. For the case of the perovskite containing lanthanum, nickel, and titanium, and strontium. Figure 5 present the effect and SEM images for the sample 1, sample 2, and sample 3, respectively. It was observed that agglomerated nanoparticles constituted the sample 1 and sample 2, while for the case of the sample 3, it was mainly composed by aggregated nanoparticles. By using the ImageJ software, it was determined that the mean particle size was 31.9, 50.7, and 80 nanometers for the case of the sample 1, sample 2, and sample 3, respectively. These results are in accord with the average crystallite size determined using X-ray diffraction results from each as prepared sample. Figure 6 present the magnetization versus temperature curve for the sample 1, sample 2, and sample 3 using a magnetic field of 100 Oersted. The figure 7 present this same figure, but only for the sample 2 and using a magnetic field of 1000 Oersted. Figure 8 present the magnetic susceptibility times temperature versus temperature curve for the case of the sample 1. From these results, it was determined that the needle temperature for the sample 1, sample 2, and sample 3 was 15, 12, and 23 Kelvin, while the magnetic moment was 1.29, 0.96, and 2.75 magneton Bohr for the sample 1, sample 2, and sample 3, respectively. The V cation arrangement was associated with the magnetization versus temperature curve as performed by Perez-Flores group and Rodriguez group. For the case of the sample 2, the short-range V cation arrangement was also associated with the magnetization versus temperature curve as carried out by Perez-Flores group for the case of the perovskite containing lanthanum, nickel, titanium, and strontium. Let's move to the conclusion section. In this work, it was synthesized nanoparticles containing lanthanum, nickel, and titanium by using the modified Bikini method, and it was employed 3 different calcination conditions. The first one used a final calcination temperature of 800 centigrades for 17 hours, and the second one employed 800 centigrades for 100 hours, and the last calcination condition was 1000 centigrades for 135 hours for obtaining the sample 1, sample 2, and sample 3, respectively. Sample 1 and sample 2 presented similar symmetry and space group, which was orthorhombic and PBNM, while for the case of the sample 3, the symmetry was monoclinic with the space group P21/N. The particle sizes of these materials was around 30, 50, and 80 nanometers for the case of the sample 1, sample 2, and sample 3, respectively. The needle temperature was 15, 12, and 23 Kelvin for the sample 1, sample 2, and sample 3, while the magnetic moment was 1.29, 0.96, and 2.75 magneton Bohr for the sample 1, sample 2, and sample 3, respectively. Random short range and Roxal ordering of nickel and titanium cations were determined in the as synthesized samples. Let's move to the acknowledgement section. The authors thank Carlos André de Castro Pérez from Instituto Federal de Rio de Janeiro. Also, they are grateful to Andrea Maria Duarte de Farias and Francisco Correa Rangel from Instituto Nacional de Tecnologia do Ministério da Ciência e Tecnologia, Tecnologia e Inovação do Brasil. Miguel and Geraldo Seniciaro and Gilder Peña from Centro Brasileiro de Pesquisas Físicas. Miguel Novak from Instituto de Física, Universidade Federal do Rio de Janeiro. Robert José Córdoba acknowledges Universidad de las Fuerzas Armadas. Mariana de Matos Vieira Melo Souza thanks Universidad Federal do Rio de Janeiro. And I acknowledge Universidad Técnica de Ambato for the support of this presentation. Let's move to the reference section. And that was the last part of my presentation. Thank you.